year 10s. So time to get started with the revision. You've done your rag of all the topics in paper 1 and the 3 topics in paper 2, which are going to be in your exam, which is going to consist this time out of 60 multiple choice questions. Now, you might think, whoa, that's brilliant. And yes, it is brilliant, but it also has its downside. And the downside is that I've made sure that I've been pretty cunning with the 3 wrong answers. Quite often there's an answer in there that students put down if they're not thinking properly. It might be a misconception that students have developed over time that I've picked up. So you're actually going to have to be really, really confident in your knowledge. But the good thing is there's no 6-mark questions this time. You don't have to show you're working out, but you do have to be confident in your work. So this is the plan. I've got 3 weeks of revision with you. Today, I'm going to focus on some real important basics, kind of the building blocks, and then I'm going to focus on some of the mathematical questions. This is because I know that you can all do multiplication, division, subtraction. I know you can do this, but some people lose their confidence and you don't need to be. So I'm going to hold your hand and we're going to walk through these mathematical questions. I've put on Show My Homework a sheet, a summary sheet, which lists all the equations you need to know and a worked example. Now this is thanks to one of you writing in and asking me for help on this, and I worked on this over this last week, knowing that all of you can benefit from this. So if you want to print that before I go through the video where I've put it on a PowerPoint, you can, but you don't need to write anything. I need you to listen very carefully. If you need to pause, stop and do so. So that's this week. Next week, those of you in school, those of you at home, I'm going to give you the same material. We're going to look at the history of the atom. We are going to look at all the different types of bonding and their properties. And then in the last week, which is actually the week of exams, okay, before you do your chemistry exam, watch this video. I'm going to look at all the different chemical reactions that we have done over the GCSE syllabus so far, which is actually most of the syllabus, to be honest, and I'm going to go through those with you. And any other work that I can pull in that time, I will do so for you. So I can't go through a year and a half, almost 2 years worth of work in 3 sessions, but I'm going to go through the most important things. So are you ready? Ready to go? Let's get started. Okay, now right at the beginning in year 9, you would have done mixtures and you would have done separation techniques and you would have done water and how do you get nice clean water. So you would have had inky water and you would have used distillation where you evaporate the water, which reaches boiling point before the ink does. The water evaporates, it condenses as it cools in the Liebig's condenser, and you get pure water on one side and you get the inky water on the other side. That's distillation, made up of evaporation and condensation. Then, number 2, if you took rock salt, you would have used a filter paper to filter the sand from the salty water. You then would have used evaporation to separate the water out from the salt crystals, which will then be crystallized. So you get crystallization. And a third separation technique would be chromatography. And this is typically used with E numbers, with dyes. And the reason is because all these different substances have different densities. And as they dissolve in a solvent, they will move up with it. Those that are less dense will zip up quickly. Those that are more dense will lag behind and move up more slowly. And scientists know the unique RF value for absolutely any substance. So if they find something strange at, for example, a crime scene, they can use chromatography and scientific data to work out exactly what that substance is. But with this comes our first calculation. So let's have a look. Here's the calculation you need to know off by heart. The RF value equals the distance moved by the spot or the solute divided by the distance moved by the solvent. So if you remember, on a line where these two dots over here, on a line out of pencil, I add my two dyes. The solvent is, or for example, the water that I stick the chromatography paper in, the line of the water is below those. So as the water starts to move up the paper by diffusion, the dye dissolves in it, and then the different colors separate out. Now they said, what is the RF value of this blue dot over here? You would measure the distance from the starting line to the middle of that blue dot, and you would record that. So you need to have a ruler, and you would divide that by the distance that the solvent moved up, and just before you stopped it, you would have marked where it gone up to, and that is what you then measure. So I've got 4 divided by 10, giving me an answer of 0.40. Now I know this is not so important for a multiple choice exam, but Mr. Gregson and I feel very strongly about this. When you do calculations, it is vital that you always show you're working out. And in this age of us doing everything virtually, imagine we would come along and virtually throttle you, because it's like throwing away marks if you don't show you're working. Don't be lazy. Show me that you know the formula that you're using, that you are substituting the right numbers in, and that your answer, of course, has the correct units written in. Never just leave a number on its own unless it doesn't have a value, like the RF value. The number is the RF value. Okay, so make sure you show all those steps. And even in the multiple choice exam, if you had a piece of paper next door to you, if you wrote those down, you would help yourself from making a mistake. And as a GCSE examiner, I go through every bit of writing that you do, and I'll try and give you as many marks as possible. So if the last thing you did was put a wrong number in your calculator, but you'd shown me the working, it is possible to get 3 out of 4 marks. So please help yourself. We don't want to go around throttling you. I absolutely promise you that. Okay. Right, so now into some really, really important basics, because if you don't understand this, when we do mole calculations and empirical formula and relative formula maths, you can get yourself into a pickle. So this is very important. If in an equation I have the element sodium, I would write it as capital N, little a, and read the question. Is it asking for the word equation or is it asking for the symbol equation? Now, because sodium is represented by the symbol Na, I can't write the A as a capital A, because if I do, then I'm going to assume that the N is referring to nitrogen rather than to sodium. Okay, so capital N, small letter A, otherwise no mark. So I've got 1 atom of sodium. And then oxygen. Now, oxygen is always O2, because when oxygen is found on its own as pure oxygen, the atoms are found as twins. So I call it a diatomic molecule. It's a molecule because it's got more than 1 atom. It's a diatomic molecule. And if you remember from the beginning of lockdown, I said to you that the diatomic molecules are the word honey, hydrogen, oxygen, and nitrogen, and the whole of group 7. And on your periodic table, which you can have beside you in the exam, you will see that that gives you a number 7 shape. So if I had to draw a picture, it would look like that. Next one. If I take sodium and I combine it with oxygen, I get sodium oxide. Yes, I turn the second element, usually the nonmetal, into IDE. It ends in IDE. So sodium oxide. Now, don't worry about how to write the formula for now, but you need to know how to interpret the formula. So I have Na2, 2 atoms of sodium, and if it doesn't have a number next to the capital, it means 1 atom of oxygen. Just like in maths, we don't write 1x, we just write x. So 2 sodium atoms and 1 oxygen atom. Then calcium sulfate. I end in ATE if the third element is oxygen. So I've got calcium and 1 atom of calcium. I've got 1 atom of sulfur. And how many atoms of oxygen? Well done. I've got 4 atoms of oxygen. So it's going to look something like that. Right, now let's crank up the challenge. Brackets. Yes, just like in mathematics, brackets means multiply. You've got it. So magnesium hydroxide, always complicated because you always want to write the H before the O, but hydroxide is OH. So in this formula, this is telling me I've got 1 magnesium atom and I've got 1 oxygen atom, but I've got 2 of them. So it's 1 times 2, 2 oxygen atoms, and 1 times 2 gives me 2 hydrogen atoms. So it's going to look like this. I can see there's my 1 hydroxide, there's my other hydroxide, all attached to magnesium. And then when I have a balanced equation, what that means is I can read it as 2 moles of sodium hydroxide by putting that big 2 in front of it. So that means everything that I had there, I've got double. So I've got a total of 4 sodium atoms and 2 oxygen atoms. Okay, got that. Now, I'm going to pause this. You might need to go and get a cool drink or just stretch your legs, and then we'll do the second part of this lesson starting from here.